everyone, welcome to Electrictron in this YouTube channel. My name is Yanira Muñoz Hadan. I am an electrical engineer, and today we're going to discuss about a new topic that is called industrial motor control. I hope you can enjoy it as much as I do, and please leave all the comments on the below this page. Okay, let's talk about the course outline. First, we're going to talk about general principle of motor control. Second, we're going to see symbols and schematic diagrams. After that, we're going to talk about manual starters, then overload relays, and finally, we're going to talk about relays, contactor, and motor starter. Okay, let's see. The first part, that is general principle of motor control, is divided by 3 sections, and each section is divided by more sections. Let's see. The first part is installation of motor and control equipment. It is divided by power source, motor connections, motor type, environment, codes, and stuff. The second section, it is called types of control systems, and it has no divisions, but we're going to see what it's about later. The third section is called functions of motor control, and it is divided by starting, stopping, jawing or inking, speed control, motor and circuit protection, surge protection, and safety. So let's see what these topics are about. Okay, but let me tell you that we're going to also see, or we're going to discuss later, about common engine failures. It is important to know that there are some problems that can make your engine to fail. They can make them fail. What are these? For example, we have to see, or we have to check the power quality that can be damaged, or can be has some distortion by transient voltage imbalance, or harmonic distortion. These are 3 main factors that can contribute to damage the power quality, and of course, consequently, damage your engine. So you have to analyze these 3 things. For the next one, of variable frequency drives, there are 3 main factors that can actually damage or can just make it work in a bad way. The variable frequency driver are the reflection of drive output PWM signals, the sigma current, and the operational overload. Third, we can have mechanical failures that can be because of misalignment, shaft imbalance, shaft looseness, bearing wear, and finally, but not the least, it's improper installation factors that can be caused by soft foot, pipe strain, and shaft bolt. We're going to see all of this at the end of the course, but it's important that you have the knowledge that we are going to talk about this. And maybe you can read a little bit, so we can talk maybe on the comments that you can write below this video. Okay? So let's start with the first chapter of this topic. Let's talk about installation of motor and control equipment. What it is about? Well, first we have to make a question for ourselves. That is, when installing electrical motor and equipment, several factors should be considered. Okay, but what are these factors? What are they? Well, first, when a machine is installed, the motor, the machine, and controls are all interrelated and must be considered as a unit. It means that everything is a body. You cannot separate things. You have to consider all as one unit. So you cannot control a motor if you're going to separate the sensor or the source, or the way that you're going to connect it so you can control it. So you cannot separate anything. To have a correct automation of your system, you have to work the sensors and the motor, the equipment, as a whole unit. Okay? Second, some machines have the motor or motors and control equipment mounted on the machine itself when it is delivered from the manufacturer. So the electrician's job in this case is generally to make a simple power connection to the machine. And you can see this machine already worked by the electrician like this figure. What we have here is a motor controlled by a simple toggle switch. Okay, you can turn it on and turn it off by a simple toggle switch. And it also has a circuit breaker to protect it for any overcurrent that we can have. Okay, let's see. Now, other types of machines require separately mounted motors that are connected by belts, gears, or chains. Not everything is about electrical motors. You can have different types of motors. That some of them are types of machines that require separately mounted motors that are connected by belts, gear, or chains. Okay, it has a new body that has these three parts, but it works as well as a motor, as an electrical motor, and you need the sensor to control it. And you need to make a system contract so you can control this according to your application. Okay, so some machines also require the connection of pilot sensing devices such as photo switches, limit switches, pressure switches, and so on. So you have to try to analyze all the devices that your process or that your industrial process is going to need. Then, regardless of how easy or complex the connection is, several factors must be considered. What are these factors? Let's see. Until now, we have seen that motors can be in several types. You can have several types of motors. One of them are just simple motors that are maybe with one simple toggle switch and with protection devices, or you can have several motors that you have to dimension according to your application, all the devices that is going to need it, so you can have what you want them to do, right? It depends on the application. Second, you can have also motors that are going to need maybe belts, gears, or chains. Then as well, you have to consider everything as one unit. And also, finally, you can have even motors that maybe are going to need pilot sensing devices such as photo switches, limit switches, pressure switches, and so on, any kind of sense. In conclusion, you have to consider sensor devices. You have to consider, the sensors, the motors as well, and all the additional devices that can complement it. So you can have an automation system. Okay, so regardless of how easy or complex the connection is, several factors must be considered. What are these factors that you have to consider? Let's see. Does the machine require single-phase or three-phase power to operate? That means that if you're going to connect it to a single-phase or maybe a three-phase, that will depend of the dimension of your application. Okay, that will depend on that. Maybe it's, for example, residential. It's used in a residential work. Then you will need a single phase. But if you're going to work in an industry, maybe you will need a three-phase power to operate your motor. So that depends on the application. So what is the horsepower of the motor or motors to be connected? That's another important parameter you need to see or you need to focus. For example, if it is a big, it is a small motor, for example, like 2 horsepower, maybe you won't be necessary for you to add some new implements. Maybe you just need to protect the motor and start it directly. Okay? But if it is in a huge scale or bigger scale, you're going to need to add more devices that we're going to see later. Okay? So it is important also to see how many motors are you going to connect. You're going to connect, okay? Third, what is the amount of inrush current that can be expected when the motor starts? That is important fact, because of this is going to depend the protection devices that you're going to need, okay? And how much is the wire section that you're going to dimension. Fourth, does the motor require some time of reduced voltage started to limit inrush current? After you analyze the third point, you're going to see, or you're going to able to see, if you're going to need reduced voltage started. If the inrush current is shorted or is a low current, not much from the nominal, it won't be necessary to use a reduced voltage started. But if it is huge, then you're going to need a reduced voltage started. Otherwise, you're going to over-dimension everything, and that is not correct. And 5, is the existing power supply capable of handling the power requirement of the machine, or is it necessary to install a new power system? Well, you have to consider that if you're going to connect your motors to the network, to the electrical network, you won't have this problem that you have to see if it's capable of handling the power requirement. Well, if you're going to connect this to the electrical network, it won't be necessary to analyze this point. But if you're going to need maybe a generator, you have to see if the generator has the power to supply this motor, or maybe or maybe, I don't know, 3, 4, 5 motors, depends on the application of what you want to need. Okay? So the availability of power can vary greatly from one area of the country to another, and we can see that it depends. The availability of power that can vary greatly from one area of the country to another. As a new thing that I can tell you, it depends on each country. For example, there are countries like Germany, United Kingdom, Australia, Turkey, United States, Brazil, China, India, Japan, that are thriving in solar and wind power energy. So the availability of power can vary greatly from one area of the country to another. That is true. So some countries need more, less, and things like that. But also, as a new point, they distribute the energy with different resources. And in a huge country, or the developed country, distributed their energy by using renewable energy. And that's an important point that we will see later. So to end this topic, we're going to see that. So to end this topic, we're going to see that power company that supplies power to heavily industrialized areas can generally permit larger motors to be started across the line than companies that supply power to areas that have light industrial needs. In some areas, the power company may permit a motor of several thousand horsepower to be started across the line. But in other areas, the power company may require a reduced voltage started for motors rated no more than 100 horsepower. And that is because of the inrush current. As you can see in this graphic, sorry about that sound, sorry for that sound. As you can see in this graphic, in the last minute that I have, there's a huge current, there's a huge inrush current when you don't use a reduced voltage starter, about 600. But when you use different types of reduced voltage starters, it reduces significantly. For example, with a wire delta starting, you can have it from 600 reduces to 200. That is the importance of using when you have huge motors, not in big scale. So let me know in the comment if you could be able to understand everything that I've said in English, and if you have some comments, you can add them too. Thanks and bye. I hope you have liked it.